Gentlemen, welcome back to the shop. Today, a treat especial, the DeWALT Brushless grind-air 60 volt max. I've been using this for nigh on a couple months now. I gotta say, quite biased. I like the frig right out of her. And I have used the Makita, or rather the Milwaukee, get the two mixed up. Almost the same color, am I right? Get the Milwaukee 4.5. Didn't like it on account of the paddle. The other thing is 4.5 inch, like this one. This is the old one. I can't believe the amount of power the new ones have compared to these old crappy ones. I've had this one for years, 2006. But if you are going to buy yourself a grinder, do not get the 4.5 inch one on account of the getting spot. The selection isn't the best. If they got it in stock, of course, the price is unbeatable. But the problem is 4.5 inch grinding discs are oddball. So it's better to go, far better to go with the 5 inch. That way when you get the 5 inch, you don't need to take the guard off in order just to use the thing. Now this, I've been using the Milwaukee 4.5 inch, the new one. And compared to this thing, I mean, incredible power. This is the old 18 volt NiCad. I just got an upgrade. When I got my dirty dick beaters around that red rigid will fuck ye tool, I thought I was in heaven. But the thing is, the 4.5 inch, it's got a paddle switch, and that paddle breaks right where the pin goes in to pivot, breaks right there, and then you lay it down and it fucks off on a low earth orbit on you. Kind of scary. So got upgraded to the 5 inch one, which is also brushless. The problem is it's a thumb switch that latches. Those things wear out. You look at the meat on there, it's just a tiny bit of meat, and they're constantly wearing out and dicking you around. So it just oodles of power on that. But the switch will dick you around. That's the red one. Also, not nearly as much power as this. Now I got this in my, this is the Cadillac of automobiles here. Killing machine proper. The Milwaukee, it'll torque out on you. So what'll happen is you're cutting some, you know, you're giving her a hot supper, and it goes click, 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 click. It's telling you it's got too much load on it. This thing just fucking powers through. Now this runs on these here 60 volt flex volt lithium ion batteries. These are good batteries. They're not as good as these bad mammoth jams. We tested them out. Just as an aside, patrons, guys, throw a couple bucks into the hat every month so that we can do cool shit. So I do not do shill vids. I do not accept merch from suppliers. One, because you don't know what you're getting. And two, I don't want to be a fucking corporal shill. Now there's guys they'll say, you know, I'm not really getting paid, they're just giving me this stuff for free and I'm gonna honestly review it. Yeah. A shill vid is a shill vid is a shill vid. We tested these batteries. These turned out on top. These were the best batteries going. More chooch for your buck. They are expensive and they work down to a slightly lower temperature. So real good batteries. These are excellent batteries as well. The problem is they're not backwards compatible in a lot of cases. Like you cannot put the 20 volt on here. It doesn't fit. Now this claim to fame is you can run the 20 volt tools. Well, there's plenty of 20 volt tools that it won't fit on. Won't fit on this adapter. Will not fit on this radio or this Bluetooth speaker. Just doesn't go, son of a diddly. So you end up needing 2 sets of batteries anyway, but you sure do get a lot of jam out of them, because boy howdy, this thing runs like a raped ape. Getting into her, this has been nutted weird. It's got a preload, spring preload on there. I would assume that's so it doesn't back off, but if you just put it on properly, and then of course as soon as you start it up, the inertia from this makes it tweak over and tightens it up on its own. But a little extra feature there. They've gone and milled 2 slots in here after the fact. You can see it's been done with an interesting end mill. It's flat on the bottom, but it's got a chamfer. If you have a look at that, a little extra process makes it more expensive. Now this thing, I think this comes off just like that. Yeah. Oopsie. And then after assembly, it's been impact printed. Little impactor goes in there, and you can see it's sat at the corner here too long. Made a hole in there. While we're ogling the outside, we'll have a look at this. This does nothing but reduce airflow. The size of particle, that looks to be about 50 or 60 mesh, 250 micron particle. That's anything smaller than that, you know, that abrasive dust, that's what's getting in there and destroying your bearings and your brushes. No brushes in this. But this is essentially just a good place for shit to clog up, and then you ruin your cooling. So I don't know if that's a good idea or not. We'll see in a few years if they continue to have these on, then we'll know. But I know the Milwaukee one, it's got the same thing down here. Doesn't do fuck all. You may or may not notice this sounds a little different, because I had been using the microphone in the camera, but I think there was, speaking of filters, there was some metallic schmoo got in there. I started to degrade the audio. Now the thing is, in the shop there's a certain sound, there's a lot of resonance from steel workbenches and vessels and so forth. But I think even worse is in the wife's sewing room. It's such a tiny little space and all sorts of rattle trappy stuff. And then we got the power supplies going and all that sort of stuff. So that's the thing. I'm afraid to tell. I'm sorry to tell you that the audio is never going to be great, because I can't. You're not. Yeah, I'm in the fucking shop. Give me a break, man. It's just us girls here having a giggle in our own shops. If you can't handle the audio, it's not to your liking, move along. And we're in like sin. Oh, molybdenum disulfide grease. Very nice. Top end grease. Here we got the crown gear carrier assembly. This is nice, man. Here's a nice shaft, all machined, powdered metal gear kind of spacer here for the bearing. This guy, though, that's a machined gear. A proper hobbed gear as well. Nice deep detent holes for the lock to get the wheel off. This little Jesus clip. See if we can get that off without blinding ourselves. That's yeah, half a blonde cunt hair size. Pretty small. That's the Australian non-offensive use of the word cunt, not North American wholly offensive use of the word. I don't get to use that one very often. My wife doesn't care for it. I go tappy tap tap. That is on there good. It needs to be pressed off. The problem with pressing is, one, you need a press, and two, you never know what you're gonna fuck up. So you got to be willing to take that chance, and I'm frankly not willing to take that chance. We're not going to hammer on her anymore, because hammering is hard on the bearings. Nice die-cast aluminum housing. Nothing wrong with that. CNC machined. No scabbiness whatsoever. No grit. Nothing left over. And nice big housing for the bearing. There's just the one bearing in there, as we can see, due to the weeble wobble. And the back bearing goes into this needle bearing in here. As we can see, lots of molybdenum disulfide particles in there. 2, maybe 5%, something like that. It's not much stiction, but that's okay, because instead of building up heat and wasting energy due to shearing that grease, because it's thinner, and you got the moly particles in there, you're going to get the lubricity from the moly particles embedding in the gear set anyway. So lots of it there. Wouldn't surprise me though if that heated up, pressurized the case. You might get a little schmoo out of here. You might get a little schmoo out of here. Speaking of that button, nice big skookum button. And there's no real shoulder to speak of. You got to have it in just the right spot. That's what you want. Because if there's too much weeble wobbling in there, it tends to tweak over, and it'll round this over right here, and then you'll never get the friggin' Jesus thing off. Overabundance of fasteners as well. Normally you'd have 4. We have 6 on here. M4s. Plenty of holding there. Not a problem at all. You lose one of those, she'll run just fine on 5. That's what you want, some redundancy. Here's the core, what contains the magnets for the brushless DC motor. We can see here it's got 4 poles, 4 magnets already sticking, getting schmoo on there. Nice feature though. We got to take that 10mm, I assume that's 10mm. Let's try it out here. 10mm nut off. Nice feature. They give us some flats in order to not destroy the shaft. Nice big bearing on the back end. They're never this big, especially for such a small little armature, or not an armature. Yeah, not to worry. And the fan, she sucks and blows, sucks in from the bottom and blows out the top, so that's kind of nice instead of sucking from, and actually makes it look like they were thinking about this, but as I said before, these just plug up and don't work for shit. I hear you. So nice big bearing on the back end. This right here, this is a segmented magnet as well, and there'll be a pickup inside of... Holy oh fuck, look at that. Pornographically copper laden. As I was saying, that little red teat down there, that little red nipple, that's an inductive pickup for a Hall effect sensor. And this just fell out. I don't know where the hell that goes. Yay. I took the pinion out of that greasy hole. It focused preemptively. Ow. Splinter, metal splinter. Nice pinion. It's been turned on a lathe. You can see the pattern there. You see the pattern on the OD. And the cheap ones are always razor sharp at this edge. You can see there's plenty of meat there. This is a nice pinion. Not a powdered metal gear. This is an expensive part. And same with this bull gear, or this crown gear. That's an expensive part. Note, however, there's no keyway, no Woodruff key, nothing like that. It gets retained strictly by the friction provided by this clamping load. This M8, so I don't know, like 4,000 pounds metric. Metric pounds, whatever the hell kilonewtons at, 20,000 kilonewtons, something like that. So guys are saying, well, it doesn't have a shear so that it can spin free if it binds up or whatever. There is so much, you would need so much torque to get this to spin free, you'd shear the shaft off. And you can see they've actually undercut it here. So if this shaft does shear, which it won't because this doesn't have enough torque to, yeah, not even close. But anyway, no keyway, and all that's providing the transfer of torque is this little nut here. Just the clamping of that little nut. Here's the fan. Doesn't move much hair at all. PA6, so nylon, glass fiber, or carbon fiber reinforced. Let's see here. Glass fiber reinforced. 30%. Here's this guy. The ducting for the van. BL4. Oh, that's polypropylene. Glass fiber reinforced 30%. Actual name brand bearing, Japanese NSK, made in Indonesia, but shielded bearing. That looks like a Viton, high temperature Viton seal. There's a W designation after the, what is it, 6009? No, 6080W. 60, I don't know, maybe 4,000 pounds dynamic load. I'm not quite sure, but that W designation means it's something special. It might be higher clearance so that it can heat up, or it might be a special seal, a Viton seal or a EPDM seal or something like that. Now you have a look at this. This has been on the pristine workbench just for nigh on a few minutes, already picking up all kinds of ferrous schmoo. So you can imagine how gooey that'd get loaded right full after a few years of service, if you get a few years out of this. Up to this point, cordless grinders have been toys, quite frankly, just for doing a little touch up, cutting hydraulic hoses or doing a little touch up here and there. You couldn't put your full 200, you couldn't go full 200 pound gorilla on any of them. This one, you can go full 200-pound gorilla. The only problem I see with this is there's no heat sink at all. There's no mitigation for heat buildup in the electronicals. You see this? It's all potted. This is encased in plastic. So if something fries, chances are it's going to be this. Now, it runs on 60 volts. So to get the same amount of power, that means less current. Less current means less heat. They might get away with it, but I have a feeling these are going to be what fries. Now, this Le Fond switch, of course, is a Chinese-made switch there and everything. Not a bad snap action. You don't want it too heavy, because then your trigger finger gets sore, but it's still a little mushy when it snaps. It's interesting that they would need such a big switch on the back end here, because essentially all the switching would get done by the brain box. I'm not quite sure why they would need to actually switch all the current. It's anyway, that's what they've gone and done. And we can see we've got leads going into the brain box, as well as some power leads coming from the battery. All these leads here are all for running these coils. Look at the size of them. Let's get in there and have a look. It doesn't happen very often, but it just so happens I'm completely wrong. This is not the brain, this is the brain box, but the actual drive is for switching these coils is in here. Big aluminum heat sink. It's all, yeah. So that's a lot better situation. There is some heat sinking there, so that's good. All this hard elastic, it's a pain right in the cunning linguals for me and you, because we can't get in there unless we cut that, but it makes it so much more skookum. It's expensive to do because it's a hand process, right? You got to get in there and do it properly and make sure it doesn't go in the hole and so forth, but it really makes the, yeah, that's nice. Like, because that way you're not having wires jiggle all over the place, and then if you do take it apart just to have a look-see, you're not worried about pinching wires and so forth. Getting her back together, noticed a couple of things. This is not nylon PA6. It's PC and PBT, so polycarbonate, expensive, and PBT, but there's no glass fiber reinforcing. So impact resistance, I mean, polycarbonate is a skookum material, and it reflects that in the price, but no glass fiber reinforcing. It's going to reduce their cost on the molds because it's not going to wear the molds out as quickly. Whether or not, it probably should be better at heat, so spatter, welding spatter, that sort of thing. Time will tell whether it wears out quicker than the glass fiber reinforcing. I have a feeling, though, it's very rigid, seems very robust. Now, getting past the honeymoon is over here. I have seen some stuff that I really don't like. And as I said, I'm not a shill. I got a job. I don't give a fuck. This overmolding crap, the butylene rubber, nitrile rubber crap, it just does not stand up. It starts to get flaky and it burns through quite a bit easier than this. It just gets gnarly after a few years. You might as well not even have it on there, I think. It seems to be more for aesthetics than anything. You know, guys now in the trades grew up watching Transformers, and it seems like all the tools, every single friggin' tool has got to look like a transformer. The windings, yes, there's a hell of a lot of copper in there. Hell of a lot of copper, but they're weeble wobbling around. There's no epoxy. They haven't been dipped. So you say to me, it doesn't vibrate much. Everything vibrates. So we're going to have wires. The size of this wire, okay, is for the ampacity so that it doesn't heat up. Why are we worried about heat? Because heat destroys the insulation. What else destroys insulation? It's weeble wobble and shaking around at 3,000 hertz or whatever this thing is spinning a thing at, actually. So while we're on the subject of spinning a thing, I did the gear ratio 3 1/4 to 1. if this is 9,000, yeah, 9,000 ripams times 3, that means this has to be 30 kiloripams, right around there. 30 kiloripams. Okay, that's pretty fast. Let's spin them a thing and pretty fast. But now we look at this. Okay, we got 6, right? And these are changing. This is essentially a 3-phase motor that's running on DC. Okay, so this one has to change polarity and then move it over, and the magnet follows it around. Okay, so if we go 30 kiloripams, 30,000 ripams, divide that by 60 to get how many hertz? That's 500. 500 hertz times 1, 2, 3, 4, 5, 6. It's got a switch. That's 3,000 hertz. This is switching at 3,000 hertz. Now, that's no big deal for the copper. That's not that fast. But for the core here, so we're taking and we're turning this into an electromagnet, and then 3,000 times a second, it's changing polarity. You're going to have a lot of hysteresis. Hysteresis is heat. Now, this is probably far more efficient than a mechanically commutating armature, but still, what I'm driving at is I do not like not having these epoxied. Weeble wobbling around, no es bueno. Another thing that's just plain wrong is the symbol here for the brake. It makes you think that there's a mechanical braking system in there, something, you know, something solid state. It's not. You're relying on the electronics and the motor to brake. So it's all electronics, and it's slowing down that way electronically. There's nothing mechanical involved here. Speaking of mechanical, this gearbox is what transfers all the torque, all the ripams to your implement, and it's painted. So a lot of heat builds up in here. These things get fucking hot. Mind you, having said that, it's a cordless tool, so are you going to be running it for a 12-hour shift? No. You're going to be running it for the length of the charge. However, you have a nice aluminum case. Why not just leave it straight aluminum? You know, a rotary tumble it, a polisher, or whatever. No need to paint it, though. That just keeps in the heat. Now, on the handle, this just feels like crappy ABS. And metric 10. M10. Yeah, nice and big. The old ones were M8 though, so it doesn't fit. And the Makita, you know, you could just grab a handle off any old one. This one, you got to keep the handle with it. So, nice and big though. This is kind of nice here. If you're into that sort of thing, you can get your, you can help your 90-pound Filipino buddy out with his contortionist routine. If you got to get in there sideways or something, a widowmaker style. That'd actually be good for getting a laugh out of the new guy. To have to grind like this, the head would be turned around. What the fuck are you doing? Now, I didn't manage to break it on the teardown, a subsequent build back up. That's the thing about good tools, is they go together properly, even if you fix them. Whereas shitty tools never go back together. The case is sprung or something doesn't want to go. So, that's a good sign. Now, before we give you the full assessment here, well, we're going to have to give her a hot supper, or at least try and break it. What the F, yo? Ah, fuck. Got the orientation of this clip wrong. Bah! Going full port crest on the old safety McGlarses today. Squints and glarses and ear hole pluggers. Here we have it. And for about 4.5, 5 minutes of regular grinding. Took a fair bit of material off though, I'll tell you that. Right, That's her. Now I had to come onto her pretty hard to get that to stall. Nice and torquey. Ran for 5.5 minutes, I was counting. So if we look at that, 5.5 minutes, that's a 2 ampere hour battery at 60 volts. So 5.5 minutes divided by 60 minutes in an hour. I will round that up to 6. That's 10% of an hour. So this thing was running at 20 amps. Sorry about that brain stall. This thing was drawing 20 amps over the course of that 6 minutes. So that's, well, that's a lot of draw for these batteries. We looked at these batteries previously. So that would be 20 amps times 60 volts. That'd be 1200 watts. This thing was averaging out at a little bit more than that because we're actually at 5.5 minutes. So say 13 or 1400 watts. So that brings it well within the range that DeWALT is claiming. It's 1700 watts peak. 1700 watts at this, that would be something like 30 amps, between 25 and 30 amps. So real hard on the batteries, but Skookum, well, lots of power anyway. As far as Skookumness, feels good in the hand, feels robust. You never know until you use the thing for, you know, couple hundred hours. My opinion, and I've had it in my dirty dick beaters now for a couple months, my opinion is this is reasonably Skookum for a cordless tool. Is it going to replace your corded tool? It only lasts 5.5 minutes under heavy use. No. But is it super convenient? Like you don't got to flash up the welder, you don't got to go and find an extension cord to run your regular grinder. Just for short jobs and for zip cutting stuff. I mean, zip cutting stuff, this is where it's at. Okay. That's about all I got for now. If and you got any questions, I made any mistakes, you want me to revisit something, please, your comment down below me in the doobly-doo. Thanks for watching. Keep your dick in a vice.